Alright, for number 1, it is a subtraction problem. We need the same exponent. Let's change this 10 to the 6th. Let's change it to a 10 to the 8th. Okay, the 4.6. Made the exponent bigger. We need to make the decimal number smaller by 2 because 8 is 2 bigger than 6. So move it past the 4, move it past one more time. What you have is 0.046. Okay, so now what you're subtracting is 7.2 minus 0.046. Okay, and that gives you 7.154 times 10 to the 8th. Right, you're subtracting 7.2 and 0.046. Okay, so this one is D. Alright, for number 2, same issue here. It's addition. They don't have the same exponents. We're going to change it 10 to the 5th. We're going to change it to 10 to the 6th. The exponent got bigger. The decimal number has to get smaller, and this time just by 1. This is 0.84 times 10 to the 6th. So now I'm going to add 5.3 plus 0.84. 5.3 plus 0.84. Okay, I'm just using the calculator here. That gives me 6.14. So I have 6.14 times 10 to the 6th. And there it is, option B. What is the answer in scientific notation for number 3? This is a multiplication problem here, so I'm going to multiply the 8.2 times the 2.5. So you get 20.5. So I'm going to write that 20.5. And add the exponents. 7 plus 8 is 15. Okay, so now I need to change this to scientific notation. I need to put the decimal between the 2 and the 0. 2.05. From 20 to 2, it got smaller. The exponent then has to get bigger to a 16. Okay, that's the answer I want, and I see it in option B. Let's take a look at number 4. What's the answer in scientific notation? So I'm going to divide here. 9.6 divided by 2.5. 9.6 divided by 2.5, and I get 3.84. 3.84. And for the exponents, I subtract them. 7 minus 3. 7 minus 3 is 4, so 3.84 times 10 to the 4th. Okay, that's option D. Number 5, a very large type of cockroach is measured at 0.00138 meters long. What's the answer in scientific, or what's the length in scientific notation? I need a number between 1 and 10, so I'll put it at 1.38. Okay, now I had to move the decimal 1, 2, 3 past 3 numbers. The number is less than 1, so it'll be a negative 3. Okay, so this one is option C. Alright, number 6. I'm going to go ahead and rewrite this over here. 9560000. Scientific notation, I want the decimal between the 9 and the 5, so 9.56. See how many times I had to move the decimal? 1, 2, 3, 4, 5, 6. 6 times. Okay, 9.56 times 10 to the 6. Notice in number 6, A is not even scientific notation. 95 is bigger than 10. Not between 1 and 10. And neither is B. Not between 1 and 10. Okay. Alright, a website gives the population of African country as 4,000,000 700,000. What is the population in scientific notation to 3 significant figures? Okay, so it wants it in scientific notation, so let's take a look at these here. Notice B is not between 1 and 10. The coefficient isn't. You know it's not going to be B. 473, not between 1 and 10. You know it's not going to be C. Okay, so let's go ahead and write the 473, and then you have, I'll just write 4732831. Okay, so I want the decimal right here between the 4 and the 7. See how many places I have to move it? Past the 7, past the 3, past the 2, past the 8, past the 3, past the 1. That's 1, 2, 3, 4, 5, 6. So it's times 10 to the 6. Okay, number 8. How is this written in scientific notation? That's just the exponent in scientific notation, so it should be 7.9 times 10 to the negative 6. Right, there's your coefficient, there's your exponent of negative 6. Alright, in standard notation, let's check the 7.9. Alright, times 10 to the negative 6, the exponent's negative, so I got to move left, and move left 6 times. So 1, 2, 3, 4, 5, 6. So I have a decimal point, and then I have a 0, 0, 0, 0, 0, 7, 9. So we got 1, 2, 3, 4, 5 zeros. It looks like it's this one. 1, 2, 3, 4, 5 zeros with the 7, 9. Okay. Number 10, how is this written in standard notation? Okay, so I have 4.6. The exponent's a positive 5. I have to move it right to the right 5 spaces. So let's go ahead and do that to the right. 1, 2, 3, 4, 5. So I have a 4 and a 6, and then 1, 2, 3, 4 zeros. Okay, so it looks like it's 460,000. Okay, so let's look at this one. Notice this number here is less than 1 for 11. Okay, this number is less than 1. So when I write this in scientific notation, 5.8 times 10, notice I have to move it 3 spaces over the 0, 0, and the 5, so it'd be 3. But this number is less than 1. This would be a negative exponent. So that's a negative exponent. The positive exponent has to be bigger than it, so it's option B. Okay. Number 12, let's take a look here. If I put the decimal here between the 8 and the 4, 8.49, that means I have to move the decimal past the 4, past the 9, that's 2 spaces, and then past the 3 zeros, that'd be 5 spaces. So this would be 10 to the 5th. This is 10 to the 6th. Okay, so 10 to the 6th is bigger than 10 to the 5th. Okay, let's take a look at number 13. Which is the greatest? Which number is the greatest? So if I look up here, I can see the exponents in scientific notation for all of them, except for the Earth's diameter. So let me go ahead and write that. 6.37. And then let's see, I would have to move the decimal 1, 2, 3, 4, 5, 6 spaces times 10 to the 6. Right, past the 3, the 7, and the 4 zeros. Alright, so which number is the greatest? It looks like Neptune is still bigger. Neptune's diameter is bigger. Its exponent is 7. The Earth's diameter is 6. Right? So Neptune's diameter is the largest. All right, number 14. We also use this table. What is the diameter of the thickness of paper in standard notation? So there's the thickness of paper. Okay, so I'm going to rewrite it here. 5 times 10 to the negative 5, thickness of paper. So let's see, here's the decimal starts to the right of the 5, and I need to move it to the left 5 spaces. Okay, so 1, 2, 3, 4, 5. There's my decimal, and then each of these gets a 0 in it. Okay, so it looks like it's C. There's a decimal, 4 zeros, and then the 5. Number 15, compare the thickness of paper to visible light. Thickness of paper has an exponent of negative 5 in scientific notation. Okay, visible light has an exponent of negative 7. So thickness of paper is bigger. Okay, negative 5 is bigger than negative 7. So we have to find one where it says the thickness of paper is bigger. Look at that first one. Thickness of paper is greater than visible light. That's the one we need. Okay. All right, number 18. Which planet has the largest mass? Well, let's look here. It's all in scientific notation, so we just need to look for the biggest exponent. So the planet with the largest mass looks to be Jupiter, with an exponent of 27 in scientific notation. Okay, so Jupiter has the largest mass. Exponent is 27. Number 17, which planet has the smallest mass? Okay, so let's look at the smallest exponent here. Mercury has an exponent of 23 in scientific notation. So does Mars. Oh, but the smallest one's Neptune. Neptune has the smallest mass here. Right, exponent is 22. Okay, so Neptune is the one I'm going to circle. And then the last question, approximately how many times bigger is Jupiter than Neptune? All right, so Jupiter has 1.9 times 10 to the 27. Neptune, so I'm going to write, so there's Jupiter's mass, okay, and then Neptune's is 1.02 times 10 to the 22nd, okay. Alright, so let's go ahead, and this is about here. This is, if I were to round, 1.9, that'd be like 2. Okay, and 1.02, well, that's like 1. 1 times 10 to the 22nd. So let's go ahead and divide. How many times bigger? So we would divide, right? 2 divided by 1 is 2. 2 times 10 to the 5th.